Hello, Chris.
Hi,
Good
thanks for
evening.
having me.
Good evening. How are you?
Yeah, good. How are you doing?
I'm fine either. Thank you. We were talking to Donovan and we asked him about a little bit of .NET questions, and
For sure.
then he said I'm not the right person,
Well,
but
hopefully I
you're the
can.
right
Yeah,
person.
hopefully I can be that right person. Exactly. So,
So stage is yours. Stage
fantastic.
is
Thank you.
yours.
Okay, so hi. So my name is Chris Sinkovich. I'm an engineer at Microsoft, and just a little bit about me. I've been at Microsoft for something like 10 years now, and I've done kind of a whole range of different roles and jobs across the company. So I actually started as a consultant back in the UK, where I'd actually go into enterprise customers and help them build big, enterprise applications and databases. I moved across to America, where I joined Microsoft Research, and I was working on computational photography, computer vision, and machine learning. And I did some of the early work of shipping machine learning as a service as part of Project Oxford, which eventually went on to become the Azure Cognitive Services. I joined .NET, where I was working on debuggers and compilers, and I was mainly focused on the debugger bring up for the ARM platform. And then finally, a few years ago, I joined the compiler team, where I've been working on C#, which is where I am today and what I'm here to talk to you about. I should say, like many people, I'm working from home at the moment. I have 2 dogs. They love to let me know when someone's walking past the house. So hopefully it's late enough here that they'll be asleep. But if you do hear them in the background, I apologize in advance. So what's new in .NET 5 for managed languages? I've got a few more slides. We'll talk a little bit about the Microsoft language strategy and where that's going. Then we're going to jump into lots of demos. We'll get Visual Studio open, show all the new features. And then towards the end, we'll take a look at where we think the language might be going in the future and how you can be involved in helping do that. So what do we mean when we say managed languages? Well, managed languages is anything that runs on .NET, right? And at Microsoft, we have 3 main languages that we support. We have C#, and this really is like our most used, most kind of feature-rich language. We have Visual Basic.NET, which has a slightly smaller user base, but still very popular, still very well used. And finally, we have F#. And so where C# and Visual Basic.NET are object-oriented sort of programming languages, F# is a functional programming language. It's really designed to work in a different way, in a different paradigm. And it's a much smaller language, but the community is like extremely involved and they're like very vocal. So, really great language there. I should say I work on Roslyn, and Roslyn at Microsoft encompasses C# and Visual Basic.NET. We don't actually work on F# at all. We obviously work quite closely with that team, so I'm not really going to speak too much about F#. But if you are interested in it, there is a new version of F# out with .NET 5. There's F# 5. And I'm just going to say there's this great blog post. You can go, it's from Philip Carter. He's the PM for F#. And it really goes into lots of detail, really explains all the new stuff. But it's also a great jumping off point if you're actually new to F#. They do things like showing you how to set F# up in a Jupyter notebook, so you can run it interactively and not have to install a bunch of tools and things. So it's a really, really great place to get started if you're interested. I also mentioned Visual Basic. Now, a lot of people go, oh, Visual Basic, isn't that dead? Well, no. Just to clarify, Visual Basic is not dead, but it is done. And what do we mean when we say that? Well, we mean that we're not going to evolve the language any further. That doesn't mean we're not investing in tooling. We'll still be shipping analyzers. We'll still be shipping code fixes. Roslyn itself, the compiler is actually shared between Visual Basic and C#. So every time we're improving Roslyn, we're fixing bugs, improving performance, both Visual Basic and C# benefit. But we just won't be adding any specific new Visual Basic language features. It's still supported. It's still absolutely a valid target to use. You can still, your existing applications are going to continue to work, and you can still build new things in it if you want to, but we're just not making any new versions of the language. So with that, let's jump into C# 9. C# 9 is the newest version of the C# language. It came out with .NET 5 in October, and it's got a lot of great features. Now, rather than showing you lots of slides, let's just jump into some demos. I've kind of broken them into a few sections. We'll go through, see different aspects of the language, and see how we've kind of improved and added things in C# I'm sure you have lots of questions, so feel free to drop them into chat as we go. We'll have plenty of time at the end to go through them. So yeah, just as you see things, feel free to drop it in as you go. Okay. So Visual Studio, great. So this first demo we have is what I'm calling quality of life. And really, these are just features that make your life as a C# developer a little bit easier. They're not going to revolutionize your development. They're not going to completely change the way you program, but they're just little things that make your life just that much nicer. And hopefully you're all familiar. It's a Hello World program, and I'm hoping you all recognize it. But when you look at it, like, there's a lot of boilerplate here, right? And so we have this new feature called top-level statements. And what top-level statements do is it said, well, why do we need this boilerplate, right? Why do we need all this stuff? And that's useful if you want to just like write in Notepad, but it's also useful if you're, learning C#, if you're new to the language, because there's kind of all this stuff, right? You're like, oh, we've got this thing, and then there's this thing, and this class, and this weird-looking thing, and you're like, what is all of this, right? And we kind of tell our users, oh, well, when you're learning the language, just sort of think about this bit and ignore all the rest, right? And we'll tell you what that means in a few weeks' time. So we said, well, actually, what would happen if you could just get rid of this, right? And you could just say, hey, so we invented top-level statements, and that's exactly what you can do. And so now in C# 9, this is a completely valid C# program, and I can prove it by running it. So, oh, sorry, wrong demo. Prove it running it. So there we go, Hello World. So we now got a Hello World program in just a single line. And you might think, okay, well, you can write statements. Is there anything else you can do? Well, you can also have functions. So we could add a function. We could make this into a nice, function. So we can say hello to Armenia as well as the world. And, again, nothing unexpected. We can now call this. So it just means that if you want to write some like relatively simple C# code, you can now do it without any of that ceremony. These are actually local functions, so they exist in the scope of the main method. And basically what we do is we take everything that's in the top-level statements and we just put them inside a generated main method. So it's just kind of the compiler generates all that stuff for you. But there's other things you can do. You may have noticed I was fully qualifying consoles, so we could have less, but you can have usings. So we can say using system, and so that's nice. We can make our code shorter and more concise. And then the other thing we can do is we can add a class. And you think, okay, how is a class a top level? Maybe it's a nested class. Well, no, actually what this is this now is a real just class. It just exists like any other class in C#. And I can reference this from my local function, just like you'd expect. But the way that top-level statements work is that it stays top-level until you see a class or a namespace. So now, if I wanted to move this function down here, this wouldn't be valid. And when IntelliSense catches up, you'll see, look, top-level statements must precede namespaces. So basically what happens is that everything up to the first class or namespace declaration, and then everything below that is now just kind of regular C#. But it means that if you want to put classes in there and still use them above, you absolutely can do that. So it means you can really just quickly get going. So it's great for learning. You're probably not going to be using it on your 15 project enterprise database app. But if you're doing new things, if you want to just quickly whip something up in Notepad, it's great for that. And it kind of gets us towards this idea of like you can do with Python, like you can do with JavaScript. You can kind of just echo some code into a file, Python that file, and run the program. And we're not quite there yet, but you can see how we begin to get there. You could imagine just echo console write line and then .NET file.cs, and then it's running a program. So we're really trying to break down some of those barriers and some of that ceremony that you need to actually get a new program going. So we have a couple of other of these quality of life things. One of the other features we've added is a thing called target type new. So for a very long time now, since I think C# 3, you're probably aware that you don't have to give the type, right? You can have the compiler infer it to say, oh, okay, I'm creating a person, so this local should be a person. But it never worked in reverse, right? If I wanted to have a field, then I actually have to put the type in. And if I try and make this a var, then it's going to say, you can't do that, right? Because they may only appear as a local. And the reason for that is a somewhat hand-wavy, complicated compiler thing, and the language rules get very complicated, so we just never been able to do it. But we realized that it would be a nice thing to do. So instead, we have this new feature called target type new, where you still declare the type of the field, but in declaring the type of field, you now no longer need to declare the constructor. So I can just say person P and new. And in fact, the compiler is going to go in and figure out that I want to call person. So that's kind of a nice little thing. And, you know, okay, it saves a little bit of typing here, but it gets really useful when you have like really complicated generics, right? So if we have some dictionary of some horrible thing of like string of int of list of int, and now I have to go and type all that in, well, instead I can just say new, right? So that's kind of handy. And then also, one of the places this is nice is if this was a public field and I was expecting to initialize it at the call site, well, up here now I can actually go in and say, okay, D equals, and then previously you'd have to write that whole type in, right? There was no way to do it, whereas now I can just say, okay, new. And so that's another place where you can use this new. And it's kind of a reciprocal feature to var, right? In the way that with var, you're sort of inferring this way. You're saying, oh, figure out the left-hand side from the right-hand side. New is sort of going the other way. It says, oh, figure out what the constructor should be from the type I'm assigning into. So just kind of simplifying your code and making it easier and clearer to write. And then we have one final quality of life feature. So obviously, like null checking is a very common thing. And from way back when, you would say, oh, well, if P is not equal to null, then, you know, use that person. It's just a string in. And then we started saying, as a language and a compiler team, actually don't do this, because this person might be overriding this not equals operator. And they can do bad things, it can be wrong. And so if you do that, you can actually end up, even though you've checked it, with a null reference exception, right? So when we added patterns, we started suggesting that instead you use an is null patterns. You say, oh, P is null. But obviously we want to know when it's not null, so we have to invert it. You end up with this kind of horrible syntax that looks a little like this. And you're like, okay, fine, it works, I guess, but it's, you know, ugly. Sorry, P is null. So you think, oh, and so then by C#8, we kind of started recommending that instead of this, people say P is object, right? And so this semantically is the same as that not P is null. It's a little cleaner, but it's maybe not completely obvious what it's doing, right? If you look at it, you think, well, yeah, of course P is an object. It's a person, it's a class, it's always going to be an object, right? You may not necessarily see that and think, oh, this means it's not null. So in C#9, we now have this lovely little new feature where you can just say P is not null. And this is actually part of pattern matching, and we'll talk about patterns a bit in the future. But it's just one of those really nice things where it's just like, you know, it's a tiny change. It doesn't change the semantics of your program, but it just makes your code so much clearer about what it's doing and just kind of makes your life as a developer that much easier. Okay, so that is our quality of life improvements. So this next demo I'm going to jump into is about records. And records are one of the really headline features of C#9. And there's something we've wanted to bring to the language for a long time, but could just never sort of quite figure out how to do it. And so it's been sort of gestating for a long time. We finally got to the point where we've got it, and we've now shipped it in C#9. So in this example, we have some imaginary system where we have a couple of classes, right? We have a point, and it has these two fields. It has X and it has Y. And we have this named point, which is some subclass, which is just a point, but it has this name, right? You can add a name. And in the semantics of our system, we say that if you have two named points, then they should be the same point, right? If they have the same X and Y coordinate and the same name, then they should be the same. But unfortunately, today, that's not true, right? So if I make a copy of this point, and we try and run this, records, then when we're going to run it, of course, we're going to say, no, we're going to get false. These things are not equal because they're reference types, right? They're classes. And it's saying, well, these are two different instances. Of course, they're not equal. So what we're saying is that we want reference types, but with value semantics. And we go, okay, well, we have a thing that has value semantics in C#. They're called structs, right? So with a struct, you rather than compare the instance, you compare all the items in it. But structs are, their own things. We say, oh, maybe we want to make this a struct, but now we can't inherit from point, right? It's saying point's not an interface because you can only have interfaces on structs. And plus, structs come with a whole bunch of other things. They have copy on write. They're not passed by reference because they're value types. And so you could sort of imagine you can make boxes, you can wrap things, but suddenly you're really contorting your class hierarchy to try and do something that's really not designed for. So you say, okay, well, we can't use structs, we have to use classes. So how can we do this? Well, we could go in and we could write equals, right? We could say, well, okay, I'll add equals, and I'll go through and I'll check the name, and then maybe I'll go to my X and Y, my base class, and I'll check X and Y, and I'll pass the base through from the subtype. But then, you've done equals, but then you've also got to do the equality operator. And then you've also got to do the not equality operator. And you've got to do things like put hash code in, right? Because if you don't make your hash codes match, then you can end up in weird situations where you put a type in the dictionary, and then you ask the dictionary if that type's in there, and it says it's not because the hash codes are different. So you end up really with like masses and masses of boilerplate code. And not only have you got to write all that, you've got to maintain it, and you've got to test it and make sure it works, all just because you really wanted to say, don't compare the references of these things, just compare their types. So that's where records comes in. So this new feature, records are a new type of thing, and they sort of sit somewhere between structs and classes. And so rather than using a struct or a class, we instead go in and say, actually, this is now a record. And in the same way that you can't mix classes and structs, you can't mix records and classes. Once you opt into records, it's kind of viral. You have to make your whole hierarchy. But hopefully, we'll show you why it's worth doing this. And so the first thing is, now once I've made these records, just all I did was change class to record. And now when I run this sample, they now compare equal, right? Because we now have value semantics. So even though they're two different references, and we can prove that by actually looking at the object reference equals. Right, these are definitely two different objects, but they compare equal now default. And so what we're doing with a record is that saying to the compiler, hey, when you compare these things, I want you to give them with value semantics instead. So that's pretty cool. But there's a whole bunch of other great stuff you can do with records as well. And one of the things is that often you want immutability when you have a record. So because they're not structs, you pass by reference, which is great. But it means that, let's say I pass this B to a new thread. Well, now my thread 2 can go and change its value, right? You can say, oh, make it 4. And now back on thread 1, when we run our equals method, it's no longer going to be true, right? Because the values have changed. But that might surprise you. You think, well, I made this thing, I passed it over here, and someone's changed it. Unlike a struct where you can't do that. And especially with threading, it could be a race condition. It could happen 50% of the time or 10% of the time. So you say, okay, well, what I want is I want to make these immutable. Right? I want to say once I've created them, they cannot change. And so the way we traditionally do that, you would say, okay, well, let's get rid of the setters, right? So we'll have just get only methods. But now, obviously, that's going to break our initialization code. It's saying, well, you sort of read-only property, you can't. So you think, okay, well, I have to have a constructor then. And then I have to pass it through, and suddenly you're back into boilerplate territory, right? And it also means you've got to get the full arguments, and there's just a lot of ceremony again for this. So records have a new feature, which we call emitters. And what that is a third type of auto property. So you had get, which would retrieve the property, and set, which would set the property. Init is a reduced version of that sort of setter, and it just says that you're allowed to set it, but only while the object is being created. And so what that means is that up here, now our initializers come back and they work, that's fine. We're still initializing these objects. But then once it's been created, once we've got this point B, there's no way we can change it, right? It says X can only be assigned in an initializer. So we can safely now create this object, pass it off to another thread, and know that nothing's going to change on it. So it's just a nice way of making immutable types that much simpler to create. We have other features as well, though. So you may notice that right now, name is optional, right? I can actually remove the names of these types, and it still compiles because it's just a property, right? It'll have its default value. And you think, well, actually, it doesn't really make any sense to have a named point without a name, right? So you go, okay, well, I'd like to make that required. Now, today in the language, we don't have a way of doing that. It's actually something we're looking at in the future. But today, even in C#9, we can't say, oh, this property must be set. So you go back to your constructor, right? You say, okay, well, now I've got to have a constructor. I'm going to have this thing called name, and then we're going to assign name to name. Okay. Well, and now we're going to have to go up here and say, okay, well, we have to put our names in. So let's put our names in. Okay, and so we now have, great, we've got a name point that does it. But when we look at this again, we've got all this boilerplate, right? And lots of duplication. We're saying, oh, there's this thing called name point, but it's also here. We've got this name, which is here and here and here and here. And then we've got this string and a string. And you're like, why am I telling the compiler the same thing over and over and over again, right? It is fine when it's just these few simple types. When you've got like 5 or 6, it starts to get really cumbersome. So we have this new feature. And this new feature is called primary constructors. And again, it's something we've been playing around with in the language for a while, but we finally got them in C#9 on records. And a primary constructor says, rather than making a method constructor, you can just put that up here on the type name. So I can say this name point has a primary constructor that takes a string name. And what this does is actually generate this whole constructor for you. And in fact, it goes a step further and generates the property for you as well. So we can now just put this single constructor and have all that code done for us. And in fact, with records, if you don't have a body, you don't even need the curly braces. You can actually just say, this is a single line. So it means that we can just simply say, hey, I want a named point. I want it to have a thing called string name. By default, they're in NIT only. That's the code we generate. And there's a constructor that will create them. So, and you can make these optional if you want and you don't want to pass them through on the constructor. So it's kind of where records really starts to get quite nice. And we can do this up here as well. I said we could make them default. So we can say int x is 0 and y is 0. And now we don't need any of this at all. And so now our entire data layer of this imaginary application is just 2 lines of code, right? And again, I can show you it still compiles, it still runs, and they still compare equal. Because they're reference types, and you might want to have control over how some of the things do, these are not just individual constructors either. You actually can pass them through to the base. So in this case, if for some reason in our application, we wanted to make a name point like require an x, we can do that. We can say that x is now a required property, and then we can pass that down to our point like so. So we have a nice way of, you can actually still do like full inheritance hierarchies with, overloaded constructors and things, but without having to then drop back to that much longer syntax. And you can see here it's now complaining because I don't have x. And then you can also do things like if you wanted to make y an optional constructor parameter, you could do that. And then you could just pass that through as well. So you can do things like that. And then in that way, you can have one which is initialized this way, and then one which is initialized using the initializer. And again, we can run this and show that they're still going to compare equal. Even though we created them in different ways, they ultimately still have the same data. So they're the same type under the hood. One of the nice things you'll get once you start using these primary constructors is, as well as generating all that equality, records will have a deconstructor. So now, by default, you can actually just pull out the things you want. So you can have var name, var x, and var y, and I can just say equals b, right? And so now this is going to call my deconstructor for b and create these x, y, and name variables, pulling them out. So that's a really nice feature to be able to, put these things into a type and then pull them apart. But the final thing you might think is, well, okay, this is great. We can get the data out. We can make these points. But what happens when I do want to change it, right? With a struct, I can just change the value because it's copy on write. Or with a reference, we said you don't want to make it read only. So we're saying, oh, well, we might want to make changes to these. So we could either create a new named point C. Let's say we wanted it to be B, but with an x plus of 1. Well, we could do a new name point and then do b.name and b.x plus 1 and b.y. Or we could use these variables here that we've deconstructed. But again, this is just a lot of boilerplate, right? And it's the same thing if you've got 3 variables, okay, maybe it's not too bad, but it would be nice if you've got 10 of them to not have to copy 9 things, right? And it kind of loses it. When you've got long things, you're like, well, what's it actually doing? You kind of miss the logic a little. So the final thing that records have is a feature called withers. And a wither basically lets you say, oh, I want to create a new point, but I want you to start with all the data fields set to the values of another instance. And so I can say I want C to be point B, and then I say, but with, and now I get the option to add new things. And I can say, in this case, I want it to be X is B's X plus 1. And this is going to initialize my point C to have this point 1 name. This will be X plus 1, so 2, and Y of 2. And so this is just a way that you can easily mutate them without having to copy all those parameters around and do all that boilerplate. So again, it's just a nice little bit of syntax that lets you easily create copies and change values. And then the final thing that records give you out of the box is that if we wanted to actually confirm these things, we can actually just print them. And so when you have a class or a struct, if you just do a write line, you're just going to get the name of the type. By default, out the box, records actually go and print all their values. So we can see that name point B has x1, y2, point 1, and this one that we constructed C is with x2. We've added 1 to the x. So it's just, again, a nice little thing that you could go and write those to strings yourself. And in fact, you can, if you want to, you can override it on record. You can actually provide an implementation. But out of the box, we're just saying, why write all this boilerplate when we can just do that for you? So it's kind of just a nice feature for working with data to kind of let you model things very quickly. So that's one of our really big features in C#, and it's one of those things that once you start using, you really sort of wonder how you live without. There we did. Okay. So the next demo we have is patterns. So patterns are a feature in C# that have been around since C# 7. But we shipped them in 7, and then we improved them in 8, and we've once again improved them in 9. And so we've just got a few, again, not altering things, but just things that make your life a little easier and make patterns a little easier to write. So in this example, we have some imaginary thing where we're saying, oh, we want to get the setting for a game, like its default setting based on the computer it's running on. And this is made up. This is no judgment on whether you like Xboxes or PCs or whatever. It's just purely an example. But we have this little hierarchy of classes down here. And you can see, again, I'm using these records, but I'm using inheritance, so it's nice. I can build my data models with just a few lines of code. And up here we have this big switch statement, right, where it says, oh, based on the different computer you're passing in, we'll make these decisions. So what improvements have we got? Well, the first improvement we've made is a very simple one, but it's a very nice one. And that's that previously in C# 8, when you wanted to match on a type, you didn't want to know anything about that type, you still had to put a discard in, right? So up here, you have to do a type, and then you have to name the instance of that type. So here, when you don't care, you have to use a discard. And in C# 9, we've just made that go away. So you no longer have to have discards in your switch statements. So you can just say, look, I just want to match when it's a PC or a laptop. I don't want to actually inspect the type. I just care about the type itself. So it's a very simple one. It was a language rule that we had in 8, and we just kind of simplified in 9 to make things simpler. The next thing we've done is it's actually somewhat, there's a new pattern. We've also improved the way the compiler reports about these patterns. So up here, we have these 2 lines that change based on the series of the Xbox you're running on, right? And so we have this simple enum. We have, this enum is an X or an S. It's just got 2 values. And then we say, okay, so when it's an X, then it's high. When it's an S, it's a medium. So there's, again, a lot of verbosity here. Maybe we want to use an embedded switch. And this we could have done in C# 8, so let's do it. And we'll say we have this Xbox, and we want to switch on its series. And we're going to say, okay, so when it's a series X, then it gets game setting high. And when it's a series S, then it gets game setting medium, right? That's what we had above. But you might think, okay, that seems sensible, but we're getting a warning here, right? And in the previous versions of the compiler, we'd get this warning and it would just say, this switch is not exhaustive. And you think, well, yeah, it is, right? I mean, I've got the two enum values and they're there, so what does this mean? And so now we've actually improved the compiler a little to give you these hints as to about what's missing. So you'll notice here it's saying actually it's not exhaustive because it has this series 2, right? And it's saying that actually because enums are just integers, a user could cast the number 2 to a series, and that's a valid thing to do. It doesn't have a name, but it's still a series enum, and pass it in, and we wouldn't match it. So rather than just saying, you know, it's not exhaustive, you're on your own, we can now give you an example of a pattern that this switch isn't going to match. And you could solve this by adding like a catch-all pattern, and this would make it exhaustive. But again, we end up repeating ourselves. Maybe we don't want to do. So we can use a new pattern that we have, which is called the not pattern. And that's what I showed you with not null. And here we can say, okay, well, when we have series X, it's going to be high. And then basically for anything else, we can say, well, actually, that's the same as saying it's not a series X, right? And so now the compiler says, oh, this switch is complete, right? We have two cases. We have it's a series X or it's not a series X. And so we could have written this with a catch-all pattern or other ways, but it's just a nice, again, improvement that we can just say, you know what, when it's not this thing, do this other thing. So what else can we do? Well, we have a few other improvements as well. So we have down here, we've got this PC pattern. And this is just, again, based on the number of CPU cores you have, it's choosing your game. So again, we think, well, it'd be nice if this was an embedded switch so we could make the logic look a little clearer. But in C#8, we couldn't because we're not switching on a value, we're switching on a range of values, right? We're saying, oh, if it's greater than 8. And you could switch on the core and do like when it's 1, when it's 2, when it's 3, when it's 4, and eventually, you know. But this is like massive duplication and it's not very clear at all. So this in C#8 was the best way you could do it. But now in C#9, we have a new feature that allows us to make this work a little nicer. So again, we're going to say, okay, when it's a PC, then we want to switch based on the number of cores. And now what we can do is where before we had to list just discrete values, we now have what are called relational patterns. So we can actually say, oh, well, when it's greater than 8, then that's when the game setting should be high. When it's less than 4, that's when our game setting is going to be low. And then finally, the rest of them, we have game setting medium, right? And so, and again, the compiler is telling us this is exhaustive. It knows that we're matching everything. And so it's just a little bit nicer that you can just do these ranges of values now. This is kind of not too confusing, but as a developer, I maybe wonder what this one is catching. And so ideally, I'd like to say, well, actually, you know, what is medium? I can look at it and go, oh, okay, it's between 4 and 8. But if you have a bunch of different switches, then maybe it's not going to be so obvious to figure out. And so ideally, I'd like to be able to put this one in the middle, right? I'd like to say, oh, the above 8 is high, next one is medium, and less than 4 is low. But today, or in C#8, you couldn't do this because this pattern would subsume the one underneath, right? It would say that, no, this is going to catch everything, so you can never actually hit this. And we had no way of saying that it was this and this, right? And so that's a new pattern we have, which is the AND pattern, and there's also an OR pattern. And what that lets me do is say, not only match when it's less than 8, but also match when it's greater than or equal to 4. And so in this way, I can actually specify a range of values that I can now put them in. And again, you'll notice the compiler's lit up to say, hey, this isn't exhaustive. And that's because I have a deliberate typo. It's saying that, oh, actually, it is not handling the pattern number 8, right? And that's because if you go look at this, you can see that I said greater than 8 or less than 8. So if I make this greater than or equal to 8. And now, again, the compiler's happy. So it's actually picked out. And, you know, maybe it's obvious, maybe it's not. But when you look at that, you think, well, I'm pretty sure I'm handling all the different integer cases, but the compiler can say, no, you know, if you give the value 8, it's not going to work. So that's a really nice, again, just a nice little quality of life improvement for the developer where we can make it a little bit easier and make your life a little simpler. And then again, down here, if we wanted to, we could make this a not null pattern. So we can just make these things a little more explicit about what they look like. And so now we have this new, slightly more laid out nicer set of patterns. So it's one of those things, and it's one of the features that's been really nice since we shipped it, that we could start with a fairly simple set of patterns in C#7, and then we've just kind of been incrementally improving it as we go. So you can do things like this, adding relational patterns, and it just allows you to really express your your business logic in the way you'd like to, rather than hiding this all between hundreds of if-else statements. And under the hood, for the most part, we'll just compile this to a big nested if-else, but it just lets you really express your logic a bit cleaner. And so that's one of the things that we really like about patterns in the C# language. Okay, the next demo. So most of these have been quite high-level features, and generally C# is a high-level language, right? It's garbage collected, it runs on, it's just-in-time compiled, it's safe, and that's one of the nice things about it, right? It's one of the reasons we like using it. It's very productive. But increasingly, as people have used it for more things, and we want to get those properties, you run into, some performance bottlenecks and things. And maybe that's not so true of application code, but it's very, very true of library code. And so if we can add low-level features to C# as well, that maybe you're not using every day, but your libraries can take advantage of, then your applications can just get faster by upgrading a NuGet package, right? And ultimately less cycles if you're on the cloud, less money. So it's kind of everyone's a winner. And so these are some very low-level things we added in C#9, but that can make a real difference. So the first one we have is a feature called function pointers. And it's always been possible to take delegates to functions in managed code, right? So it's up to today, we have a predefined one called func, and we say what the input is. We say a func takes an integer, it returns a Boolean, we give it a name, this is going to be our func, and then we can say this is c.call, right? So this now means we've got a reference to that static function, and we can invoke it with an argument if we want. And so this is nothing new. These are delegates. But the thing about delegates is that they are actually a mechanism under the hood, right? They're an indirection, and that's great because again, it's a safety feature. It means that you can't accidentally call the wrong things. You can't mess things up. But if you're using them for high-performance code, then there's an overhead there, and you might want to say, actually, I'm willing to take the risk, but I want it to be much faster. And so that's where we introduced function pointers as opposed to delegates. And so you'll notice I'm in an unsafe block because ultimately it's a pointer, and so it has to be in an unsafe block. But the syntax is a little weird, but it essentially matches the func syntax above. So we say we want a delegate pointer, and then we say what comes into it, what goes out of it, give it a name. And then rather than taking a reference to the function, we actually take the address of the function itself. And so now at this point, we have this pointer to that function, which is not a delegate, right? It's just an actual function pointer to this static function. And again, I can call this here just like I would with a function. And if you wanted to run it, oh, wrong demo. If we wanted to run it, then, not very exciting, but we can see that it's calling those functions through indirection. But the second one is just that much faster. And where this really comes into its own is that function pointers don't have to be to managed code. So traditionally, when you're interoping with, say, C++ or Rust, then you end up having to use pinvoke. And when you want to do callbacks and things, you have to have a delegate, and then that gets marshaled. And so if you're trying to call in and out of code, it can be quite a performance bottleneck. Whereas now you can use function pointers, just take them. And so these function pointers can have different types. So by default, they're managed, and that's just what you get. You can also specify that they're unmanaged. And then even further, you can go in and say, actually, you actually have access to things like the calling convention, right? So you can actually go in and say, oh, not only is this an unmanaged call, this is like a C declaration call. So it's how it passes the information to the registers. And so again, this is probably not something you're going to be using in day-to-day, but it means your libraries, things like SQLite, which has a native library under the hood, can now start taking advantage of these. And so all you have to do is upgrade your packages, and your application just gets that much faster. So it's kind of a nice feature in that respect. In the same vein, we have another new feature, which is called native integers. And so since, forever, you've been able to create an integer, but that integer is absolutely a 32-bit integer, right? It doesn't actually matter what platform you're running on. Even if you're running on x64, it's still a 32-bit integer. It's just defined in the CLR that an int is 32 bits. And that's, useful, fine. But if you want to pass these things down to C in native code, then that doesn't work, right? Because in native, an integer is going to be 64 bits, not 32. And so you have to either if-def things, or we have this thing called int pointer, right? And so I can make an int pointer. But these things are actually a struct, and so I can't just use them like a number like I'd like to. I have to actually create them. And you can do things like add to them if I want to, but under the hood, that's still a function call. And although it's quite optimized, again, it's still just these layers of indirection where really you just say, I just want an integer that changes size based on the platform. And so for that, we have this new type. It's a new intrinsic type, which is called nint. And so nint is a platform-dependent type. So you can see here it's saying it's platform specific. So when you're running on a 32-bit system, it will be 32 bits, and when you're running on 64, it will be 64 bits. And that also means we can do things like when we want to do arithmetic on it, this is no longer a function call. So if you look at the IL for this, it's just a straight IL add, right? Because we know that it's just a number, and so we have a representation now in C#. So again, it's one of those things that, like, it's not that useful for most things, but for the specific cases, it really makes a huge difference. And so you can imagine now that we could make this, if this was some native function, we could say, actually, this is a nint, and now we can call it with a nint, and it means that if it's on 64-bit, then it's going to be a 64-bit integer, and if it's 32, it's 32. So that's pretty nice. There's also the new int unmanaged, unsigned variant as well. So there's an unsigned integer that changes sizes. So these are just kind of some examples of how C# really runs the gamut, right? From like very high level code, which was like, I'm going to delete the main methods and just write some script-like code, all the way down to we have function pointers and native integers that change on the platform size. And so C# really is quite a mature language now, and it really has a whole bunch of different use cases. But we do really try and rev across the board as much as possible, so that you as a developer can make nicer programs and do things like is not null, but also library developers can make your life better and faster. And so the final demo I have is actually not a language feature. So these were all new in C#9, but we also have a new feature called source generators. And source generators are actually a compiler feature. You don't need C#9 to use them, although they did ship in the same compiler in Roslyn 3.8 that C#9 came out with, and we actually made a few additions to the language to make things nicer for source generators. But source generators are essentially this idea of, I would like to plug into the compilation pipeline at compile time. And so for things like dependency injection or like aspect-oriented logging frameworks, a lot of these things run using reflection at startup. And that, it's fine. It's the only way to do it today. But obviously, that's just like wasted effort if it's the same thing every time. And especially on things like web services where your time to live is really important, that can be a significant bottleneck. So, there are some tools out there. You can run things in MS Build. You can do IL weaving that do these. But they were never really integrated into the system, and they were never particularly easy to use. And so source generators aims to fix that. And so we've always had analyzers ever since we shipped Roslyn. And so we based it on a similar model of analyzers. So analyzers are separate assemblies that run in the Roslyn compiler, and we give you full access to the semantic model. So you're not just left reading text. You can actually go in and say, oh, is this pointer here the same as this pointer here? And the compiler can tell you, right? You have a full ability of the compiler at your fingertips. And so source generators does the same thing, but rather than just issuing diagnostics, you're actually allowed to add new source to the compilation. And so we have this simple demo. I'm not going to really look at the generator too much, but you implement this thing called iSource generator, and we'll call you back. And you can use the Roslyn API to go in and do all sorts of things. You get full semantic analysis, and then at that point, you can generate new source code. And what that lets you do when you're consuming it is, here's this example we have. It's an example called auto-notify. And so if you've ever written WPF and MVVM and view models, then you'll know that you have to do iNotify property changed. And it means you end up with quite a lot of, again, boilerplate code in your view model. And so auto-notify fixes this by saying, you add this attribute to any of your fields, and the generator, when we compile the program, will look for this. It will say, okay, I will generate a corresponding property called text, and I'll put that notify changed in. And so that's really nice that you're no longer worried about bringing into MS Build. You no longer have to worry about like IL weaving and things afterwards. All the tools just work together. It's just supported in the compiler. But even better than that, it's not just supported in the compiler, it's supported in the IDE. So what we can do is down here, even though we can see we haven't declared that property, when I dot into it, you can see that it has this text property, which is being generated by the generator. And what's even better is this is live. So I can actually say, actually, I'd like this amount property to be, amount field to be a property too. And I haven't even saved the file. I haven't hit build, but now suddenly here is amount. And so the generator is actually running as you type your keys, like as you type in Visual Studio, we're running the compiler. The compiler is taking all the code that you've got, it's passing it to the generator. The generator is doing semantic analysis and says, oh, okay, I see that you want to generate this code, adds it, puts it in, and then passes it back where IntelliSense can then find it. And we can do things like, you know, this is entirely up to the generator, but in this particular one, we have things like we can control the property name, right? So if we wanted to call this like price or something, now again, I can come down here, and now suddenly this amount is now called price. So it's just a simple example of how you can plug into the compilation pipeline. And you can imagine doing this for DI. You could have it, you know, build all the frameworks at compile time, so when you launch your application, it's just all there ready to go. So this is a pretty new experimental, it's not experimental, it was in preview for a while. We shipped to V1 in Roslyn 3.8. We have some new APIs coming in 3.9 with Visual Studio 16.9. But we're very much still at the beginning of the journey for source generators. It's certainly seen a lot more interest than we perhaps thought it would. And so we're really wanting to keep evolving the feature. So if you have a play with this, we're always looking for feedback. We've seen some people do some really fantastic things with it. So, you know, let us know, and we really do want to hear what you're doing with them and how we can improve the experience. Okay, so that's all my demos. I have a few minutes left and then we'll take questions. But just before we do that, let's talk a little bit about the future of C#. Obviously, we're not stopping there. We have some great ideas of where to go next. One thing we've talked about is doing struct records. So in the same way that you have the, records today are basically classes, they're reference types. You could imagine having records that are value types. And although they already have value semantics, they would get the new equality, etc. We have potentially discriminated unions. This is where you can have a type which is actually two types, and you can use things like patterns to find between them. Required properties, I mentioned this as maybe something that we wanted to do, where you can say, oh, I don't want to have a constructor, but I require you to have this property. And then a new thing which we know is coming is declarations of variables and deconstruction. This is a really small feature where today in a deconstructor, you have to have either all declarations or all locals, and this just lets you mix. And the reason I bring this up is because this was actually a community contributed PR. So this was actually a member who was not part of Microsoft, looked at the feature, implemented it, and worked with us to implement it. And so that brings me on to my final thing, which I would say that Roslyn is open source, so feel free to get involved. We're on GitHub. We take pull requests. All our issues are open. And as is the language. So if you want to suggest language features, if you want to go and tell us what you want in the language, you can go to C#lang and we'll work on that. We review it twice a week in LDM. And say we do have contributors, we have people who are working. Right now, where we haven't settled on C#10 is a great time to go do this because we're actively deciding what we want to ship next. So if there's things you're interested in, go there, let us know, and we will make sure we get them in the next version of the language. So with that, thank you. That was hopefully a whistle-stop tour of many of the new things in C#9. And maybe you have questions.
Well, I believe that because you explained everything so smoothly, there were nobody busy typing the questions, and I believe now we have a time for asking the questions. Guys, feel free to write comments as questions and also post with hashtag. I'm checking the hashtag all the time, and still nobody asks any question with that hashtag. So if you have any question.
I was going to say, I would just say as well, speaking of Twitter, as well as being open source, most of the compiler developers, we are on Twitter. There's also people on Discord and a few other of the services. So if you are interested in getting involved, come chat with us. We're pretty friendly. We like to help people do issues. We have up for grabs and things. So if you want to, take something and work through it, we'll happily help you and get you up and running. So yeah, come check us out. I'm Chizza99 on Twitter, and there's at Jared Parr, who is the head of the compiler team. He's also very active and is very responsive on Twitter.
Nice, thank you. So maybe before the guys will ask questions, maybe I can ask almost the same question I asked to Donovan.
Yep.
For those who just starting their career in IT, what would you suggest how to start it and what to invest in?
Yeah, and I mean, I think it's in many ways it's an amazing time to be starting in the field, right? Because there's so many options and there's so many different things you can do. And I think the advice I always give someone starting out is find something you're passionate about, not necessarily the language, not necessarily the technology, but really a problem you want to solve, right? When I first started getting into programming as a teenager, it was because I saw problems with the computer and I was like, I really wish I had a thing that did this. And so then that gives you that drive to go do it. And so I kind of say that way as well. And especially with things like Node and Python, today it's very easy to just kind of take a few building blocks and glue them together. And people can be quite dismissive of that, but it's such a great way to get into programming. And just to say, actually, not, oh, I'm going to take this big thick book and learn this is a while loop, this is a for loop, but actually, oh, this is a problem I want to solve, or I want to build this website, or I want to, come up with this machine learning algorithm. How do I do that? And so start from the problem and then figure out the tools you need to actually implement that. And that kind of always gives you the drive and the determination to actually see it through. And there's nothing better, right? Like if you're a programmer, I'm sure everyone agrees, and when you finally get it working, you're like, you've been sat staring at the screen for hours and it finally works. And so I think that's kind of really the advice I give everyone, is just find something you're passionate about and then use programming as a tool to enable that.
Nice answer. So of course you said it doesn't matter, but I would ask why they should start with .NET, not with other technology.
Yeah, I mean, the nice thing about .NET is that it's really mature, and that kind of used to be not a good thing, right? When we had sort of .NET 4.7 and it got a bit all slow and clunky and Windows only. But now that .NET Core is everywhere, it runs on Mac, it runs on Linux, but also there's huge libraries of code, right? And so, I mean, C# now is nearly 20 years old. So as a language, it's very, very mature. There has lots of options, which can be a little overwhelming, but it also means that when you want to search for things, they're there. There's very well-established patterns and practices of how to do things. And we have quite a lot of opinionated code in it. So it's one of the nice things with .NET. And again, with things like NuGet, you can quite easily start gluing things together to create quite performing programs and services that even if you're like, well, it's not a lot of your own code, you can actually still scale it up and get it out onto the web and have a lot of people using it very, very quickly. And so that's one of the nice things about .NET, is really just all that support that comes from it. And obviously we have things like Visual Studio Code. I mean, I grew up with Visual Studio and it's completely free now. So like, if you've never used a debugger, it's kind of one of those magic things, and you show people like, oh, you can debug log in JS, or oh, I can step through this code and show you the live state of the variables and change them as I'm writing. It's kind of one of those like black magic things. So that's kind of really the strength of .NET, is just the ecosystem that exists around it, as well as just the languages that support it.
Yeah, right. So for me personally, it's because documentation. I never saw any technology that have such a beautiful documentation, which is explaining almost everything. You can find the answer of almost everything on docs.microsoft.com. So that's the best part for me.
Yeah, no, I mean, it's something we try and be passionate about. We, think that is ultimately, I think it's Miguel de Casa always says this, right? He says, if you want to do one thing productive today, go and write documentation, because you'll unlock many more developers than you just writing some code. So I think absolutely, it's a really great thing about .NET.
Right. Okay. So I got like personal interest, and I will use my opportunity of asking the questions. So, what is the tools you use every day in your development process? Like programs, like tools?
Yeah, I mean, really, I do just live in Visual Studio, right? We really do. I mean, our team is probably these days 50-50 between Visual Studio and Visual Studio Code. Several of our team members have Macs or Linux. I'm a Windows guy, have been for a very long time. I love VS. I think it's just the most productive environment ever. I do also use VS Code. I mean, I mainly use it for editing Markdown for documents, but it's there and that's useful too. And then otherwise, everything is done in GitHub for Roslyn. So, I mean, I basically live in the command line. I use Windows Terminal. I actually use Git Bash as my main shell, just because it's sort of Windows and Linux mixed. And so, yeah, really, it's just Visual Studio, Bash, and GitHub.com is really how I do my development.
Nice. Honestly, I started using more code than Visual Studio because it's light, and at the same time, for me, there's honestly no difference between these two editors. Both of them are rich functionally, so
yeah, no, I mean, VS Code has just been like such a runaway success, since we launched it, and it just has such an amazing user base of people, and so there's so many plugins and things you can do with it, and it really is, yeah. And we, for a few years, the C# support wasn't quite as good as it perhaps could have been, but really it's gotten, I think, a lot better in the last couple of years, and now we're really saying that we absolutely see VS Code as a first party. Well, I mean, obviously we make it, but as a first target for C# and .NET development. So it's definitely something we intend to keep just making better and better.
Right, thank you. And this new command line tool, Windows Terminal, which is perfect option if you're using all command CLI tools and command line tools.
Yep.
And that's it. And many people didn't notice, but now GitHub have its own CLI,
yeah,
which is different than Git CLI, which is
so
really
you can do things like open a PR from the command line, which is great. So if you have a branch that we work on a fork model, right? So I have my own copy of Roslyn in GitHub. If I want to submit a PR to Roslyn, I can just type GitHub PR create web, and it will open the web browser for me with everything set up. So that's where, if you're interested in sort of optimizing your workflow, then the GitHub CLI is really, really helpful for that.
Yeah, because for some quite been long time, it's been like when you're teaching a new student to programming and you're saying like use Git on command line, and then you say, no, now open the website or desktop application of GitHub.
Yep.
There's always question why I should use user interface if I'm using command line interface, and now it's combined. Just use both in command line and it's perfect.
Yeah, no, it's very nice.
Right. I have had one last question, but I forgot it.
Well, if people do have questions, like I said, feel free to ping me on Twitter. I mean, we're always open. We're always happy. I think my email, I'm chsienki@Microsoft if you want to talk to me there. So, feel free to reach out with questions. It's always great to meet people that are using C#. So
nice. Thank you so much for joining us and for taking your time. I know it's late up there.
Yeah, it's definitely time for bed now, but
yeah. Donovan didn't agree with you.
My wife is going to tell me it's bedtime, I think. So
nice. So thank you for joining. Thank you for being with us today, and thank you for your presentation. I hope we will have opportunity to see you more.
Absolutely. Thank you so much for having me. Thanks.
Bye.